Deep time, taught as fact in essentially all the educational institutions of our land and reinforced by the media, represents a direct frontal attack on the truthfulness of Scripture. On today's program, we'll show that carbon-14 is now the friend of those who accept the Genesis account as historical. There is overwhelming evidence of only thousands of years, not billions. Coming up on today's edition of Origins, Deep Time, Deep Deception, Part 1, with Dr. John Baumgardner. Hello and welcome to Origins. I'm Ray Heipel. It's an honor to be your host today. During this program, we showcase interesting guests who present evidence from science, along with other important facts, validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. John Baumgardner, is Research Professor Emeritus in the School of Engineering at Liberty University. He has a PhD in geophysics from UCLA and worked at Los Alamos National Laboratory in computational physics during most of his scientific career. Since the early 1980s, he has provided most of the primary research on the concept of catastrophic plate tectonics in connection with Noah's flood. He was also a part of the RATE team, which discovered radioisotope evidence that the Earth is young. Welcome to the program, John.
Thank you, Ray. Thank you.
We're talking about deep time and deep deception. What does that mean?
Well, I'll get into that in a moment, but I want to start with a rather provocative statement, namely that the concept of deep time has all but destroyed the authority of the Bible in the minds of most educated people today.
That is a shocking claim. What do you mean by that?
By deep time, I mean the proposition that the Earth and most of its rocks and fossils are in fact millions to billions of years old. It's essentially equivalent to the belief in the standard geological timescale and the validity of radioisotope dating.
I mean, this is just matter of fact in pretty much all the textbooks, high school, college, that this is just what is true.
Right. It's the default position. It's in all the TV documentaries, in all the museums, in all the textbooks. There's hardly any challenge to that view today.
In fact, if you do question it, you're probably going to be ridiculed or thought of as less than intelligent.
Right. There's hardly anyone willing to take a stand against it today. So just why is deep time so devastating to biblical authority? Let's just consider one issue, namely how long have people like us been on the earth? According to the deep time estimates, the answer is at least 200,000 years.
So this is when, whether they call it Homo sapiens or whatever it is, modern humans, as it were, first appear.
Modern humans that bury their dead, make tools, have complex society, or at least structured society appear.
200,000 years.
Yeah. But according to the Bible, there were only 20 generations of people between Adam and Abraham.
And we can count them in the books of Luke and 1 Chronicles and others.
Yes, they're recorded in Genesis, the early chapters of Genesis, gives them by name. Those names are repeated in 1 Chronicles chapter 1, repeated in the New Testament, in Luke's Gospel. The ages of the patriarchs when their sons were born in these genealogies limit the time span between creation, the creation of Adam and the birth of Abraham, to less than some 3,000 years. By contrast, applying radioisotope dating methods to date human artifacts and human remains yields a date of some 200,000 years for the earliest people like us. Using that number and assuming 25 years per generation implies that there were roughly 8,000 generations between the first humans like us and Abraham, according to the deep time picture.
So we have a problem then if we're going to understand the Bible as true and try to reconcile what modern science is saying. that's not going to work.
It doesn't work. 8,000 human generations before Abraham makes it impossible to interpret the text of Genesis 5 and 11 as real, genuine history. Instead, the text must at best be regarded as allegory or myth. This implies that the individuals named in the genealogies of Genesis 5 and 11 must likewise be understood to be allegorical and not real historical people. This includes not only individuals like Enoch and Lamech and Peleg, but also Adam, Eve, and Noah.
Now we've got a real problem.
Now you're starting to see the problem.
Mm-hmm.
And if Adam and Eve are not real, if they're not real people, that are real historical people, and their temptation and fall as recorded in Genesis 3, that history cannot be true historical history.
So our Christian faith, and I'm sure you've heard this, I've heard this, that people, well, all we need is to trust in Jesus for the forgiveness of our sins, and we really don't need to worry about these early chapters in Genesis, and yet the person and work of Jesus depend upon the truth of these early chapters in the Bible.
Right. And in addition, because the geological record for the past few thousand years, according to the deep time dating methods, contains no evidence for any global water cataclysm, the flood of Genesis 6 through 8 must also be no more than an allegory if you're using the deep time methods to date the rocks. And so that so the flood becomes non-history and it's some kind of an allegory. But this is consistent with the deep time logic just mentioned, that the individuals in those genealogies, including Noah, must be allegorical.
So the flood didn't happen, Noah wasn't a real person, Adam wasn't a real person. The Bible's got some neat stories, maybe we can learn some moral lessons from it, right, but it's just not true.
Yeah. I would call what we're dealing with, satanic poison, spiritual poison to the soul. Making it very difficult for a Christian today to trust the Bible.
It reminds me of Genesis chapter 3 when Satan appears in the form of the serpent and says to Eve, "Hath God said?"
That's right.
I mean, it's as if he's saying that about the whole Old Testament to us. Did God really say these things? And science is saying, well, no, he couldn't have said them.
So if deep time is real and Genesis 1 to 11 is not authentic history, then the New Testament simply cannot be God-breathed and true. I'm saying that there's no other conclusion that you can reach.
Jesus refers to Noah, he refers to Sodom and Gomorrah, he refers to Jonah, he refers to Adam, he refers to all these people as if they really lived, and I guess he must have been wrong.
Right. So if Noah and the flood isn't true, Jesus' comparison with his second coming with
As
Noah,
in the days of Noah, that's right,
means that Jesus didn't know what he was talking about.
The days of Noah were myth, well then my second coming is a myth as well.
So it's devastating, devastating to biblical authority. For me, a person therefore has a sober choice to make, a Christian. That choice is between either embracing the concept of deep time or embracing Jesus and the truthfulness of the Bible's account of the history of the world. There's no middle ground. There's no compromise position.
There are two contradictory truth claims, and they can't both be true. Therefore, one of them has to be false.
Yeah. The widespread acceptance of deep time has decimated biblical Christianity in Europe, especially Western Europe.
The churches are empty.
Yeah. So why has this deception been such a formidable stronghold and so difficult for those loyal to Jesus to overthrow? Why have we not been able to expose this as deep deception? Why have we not been able to find the scientific error?
That's right.
So that's what we're going to talk about. And the answer to that is the difficulty of identifying the flaw in radioisotope dating methods.
So this is what they use to say the earth is old.
Right. It's the primary means that is used to date rocks and to conclude that the Earth is millions and billions of years old.
If the Bible's true, then their dating is wrong, which means their dating method has to be mistaken in some way.
That's right. So let's go back and look at a little history of radioisotope dating. By 1905, less than 10 years after the discovery of radioactivity by Becquerel and Curie in France, it was realized that the decay of uranium to lead could be used to estimate the age of rocks. From an early determination of the uranium half-life and the measured amounts of lead in some of the first rocks analyzed, it was soon accepted throughout the academic world with a high degree of confidence that the Earth was more than 1 billion years old. That happened in the first decade of the 20th century.
Well, I'm sure this made a lot of secularists very happy.
Yes. For secularists in general and atheists in particular, those findings were cause for great jubilation. For them, the radioisotope data established beyond any serious doubt that the Earth was billions of years old, that evolution had to be true, and that the Bible was no more than a quaint myth.
You know, this is a warning to us as believers too, because they already wanted to believe this. And so as soon as they had something that indicated it, rather than question it, rather than really subject it to critical thinking, they accepted it because it said something they wanted to be true.
Exactly, exactly. So let's define some terms here. First, a radioisotope. What is a radioisotope? Well, it's an unstable form of a chemical element that emits various types of radiation as it transforms spontaneously, usually to some other element. And the example I'm using here is an atom of polonium-239 that decays by emitting an alpha particle and turns into a uranium-235 atom.
Okay, this chemical element is in the rocks.
It's in the rocks.
Okay.
Yeah. We're talking about a spontaneous transformation of an atomic species to another atomic species, and with the emission of some radioactive particle.
And we can see that, we can examine that it's happened.
Yeah, we're going to measure it in the laboratory, measure how fast it happens in the laboratory. Another term that we use is that of half-life. Half-life is the amount of time it takes on average for half of the original radioactive atoms to transform to another type of atom or atoms. This example here, if you start with 1,000 radioactive atoms, after one half-life, which I'm assuming here is 3 days, you'd have only 500 atoms. After another 3 days, only about 250 atoms, and so on.
If it's constant, it would always, the half-life would always be the same.
Right. So because radioisotope dating represented such a formidable and unanswered challenge to biblical authority, in 1997, the Institute for Creation Research launched an initiative to identify the fundamental errors in these dating methods. So a team was put together involving the 7 scientists in the first 2 rows here. And I won't name them all, but I'm included, and Larry Vardaman with the Institute for Creation Research headed up the effort, was the organizer, fundraiser, and coordinator. And we call the group Radioisotopes in the Age of the Earth, or the acronym RATE.
So the RATE team that I mentioned in the intro, this is where that comes from. You were part of this original team.
Right. So during the next 7 years, we undertook several separate research projects to find the answer to this huge challenge. And God answered our plea for His help in several wonderful ways. Our team confirmed that C14 is present in all carbon-containing fossils at levels far above, typically 200 to 400 times above the detection limit of the instrumentation. So there's no doubt we were observing, and others were observing, real C14, way above the detection level. According to the usual C14 dating assumptions, the measured C14 levels imply that fossilized organisms are no more than about 50,000 years in age, regardless of where they occur in the rock record. And I'll go into that a bit more. This result is radically at odds with the deep time ages that commonly range from millions to hundreds of million years for fossils.
That's absolutely correct, because if you go just from, even some of the dinosaurs being, around 100 million years, to get to 50,000 is a radical drop, but still we're not within the biblical time frame,
yeah, I'll get to that in a moment. So this result, it turns out, was already documented in the peer-reviewed C14 literature when we started the project.
So they already knew that the levels were not consistent with what
That's right.
the textbooks were
saying.
They
already knew that. So that there were organic samples from every part of the fossil record that contained high and consistent levels of C14. This was already in scores of academic publications. This inconvenient truth had been explained away as what they called in situ contamination.
Now, what do they mean by that?
That means that the contamination didn't occur in their laboratory. It somehow got in the sample before it got to their laboratory,
so
in
the
situ
samples,
in the ground.
All of them weren't saying what they should, so they say, well, the samples are somehow corrupted.
Yeah.
That's pretty convenient.
Yeah. So here are some examples from the standard literature that reported, in all cases, given their place in the geological record, they ought to have 0 C14. The C14 half-life is short. All right, so here we have some of the papers and some of the material that was dated using C14. Involves coal, wood, shell, and so on.
And those numbers on the far left, that's how old
that's the
C14
age,
is
the C14 age that was obtained.
44,900 years, 45,200 years.
Yeah.
John, just before the break, you mentioned C14 or carbon-14. What is that?
It's one type of carbon. All the various forms of carbon have 6 protons in the nucleus. But the different types of different isotopes, are called, of carbon, have different numbers of neutrons. The most carbon is carbon-12. It's got 6 protons and 6 neutrons in the nucleus. There's a carbon-13 that has 7 neutrons, and carbon-14 has 8 neutrons. Carbon-12 and carbon-13 are stable, but carbon-14 is unstable and decays to nitrogen-14 with a half-life of about 5,700 years. Half of it disappears spontaneously.
So by measuring the remaining carbon-14 in fossils, we can determine how old they are.
That's right.
All right, John, so your group looked at the carbon-14 in these samples, and what did you find?
Okay, aware of these results already in the C14 literature, we undertook our own experimental effort to verify them. And our approach was to get 10 coal samples from the U.S. Department of Energy Coal Repository at Penn State University, and we had these analyzed at one of the best C14 laboratories in the world. And our samples were from 10 separate major economic coal deposits across the United States. And here are the results that we obtained. We have the name of the coal seam, the state and county where it was located, the geological interval, and the ages for these samples range from around 40 million years to 315 million years. And yet the C14 age that was obtained by the laboratory is, all of them were in the range of 50,000 years. The average was 49,600 C14 years.
So the average for all of these samples, and these are some of the best samples, as you said, that you were able to get tested in this laboratory, going from millions of years for each one all the way down to an average of 49,000.
So basically, we simply verified what was already well established in the C14 professional literature.
And this would just be written off as what? In situ contamination?
Yes, they would say that somehow this C14 got into the samples before it came to the laboratory.
Okay.
How it happened, they have no answer.
Okay.
The standard ages for these rocks were from 40 to 315 million years ago. Statistically, however, we saw no difference in the C14 levels from the youngest to the oldest samples. This suggests that the plants that form these separate coal deposits all grew on Earth at the same time and not so long ago.
Now this is referring to the fact that the carbon-14 is found in what would have been living fossils, the plants.
Yes. So why did our samples give C14 ages of about 50,000 years when the Bible indicates that the flood took place only some 5,000 years ago?
All right, this is the question I've been waiting for you to answer.
Okay, the answer is that a standard assumption made in C14 analysis is that the atmospheric C14 level when the organism grew, when it was alive, was close to the same as the level we measure in the atmosphere today. That's just a simple basic assumption. However, for organisms now fossilized deep in the rock record, this assumption is almost certainly not valid. There are good reasons to suspect that the atmospheric C14 level before the flood was much, much lower than it is today, and that readily accounts for the difference.
So would you say it's fair to say that the secular scientists are assuming a starting point that just isn't correct?
Yeah, well, they're not even thinking that that these samples that their other methods give, which give millions of years, could possibly be young. So the C14 is normally used only for dating things that are just a few thousand years old. So they don't even think about the possibility that C14 could be the true age for these coal samples and the bone samples, shells that they're measuring.
So they have another standard of measurement that says it's much older, and that must be right because that's what they want it to be anyway.
They're convinced in the truthfulness of deep time. So in summary, the C14 levels we measure in fossils today powerfully testify that all fossilized organisms lived thousands, not tens or hundreds of millions of years ago. They also testify to major inconsistencies among the deep time methods. So in our next program, part 2, we'll look at additional rate findings as to why deep time is deep deception, looking at these other radioisotope methods. So this is the team that basically was assembled by the Institute for Creation Research in 1997. And the 7 PhD scientists that did the research are in the front 2 rows here.
Okay.
We also reviewed a key finding of the rate team, namely that significant levels of C14 are present in all carbon-containing fossils throughout the rock record. One thing I failed to mention in that part 1 is that the team also found C14 in diamonds, which is a staggering result because diamonds are supposedly several billion years old, and finding C14, which has a half-life of only a few thousand years, is simply unthinkable if those diamonds are really billions of years old.
John, was that the first time that carbon-14 was identified in diamonds?
Very first time. No one had even thought of analyzing diamonds for C14.
What was the reaction in the secular community to that finding?
Largely unbelief. They just could not imagine it. But after we measured our C14, a secular lab in California checked diamonds for C14, and they found the same results that we had reported. they found the same levels of C14 in their diamonds as we found in ours.
So I'm sure they've adjusted their dating methods and say the Earth is only a few thousand years old, right?
Yeah, of course.
Another example of contamination.
Yeah, they
sure.
just passed it off as contamination.
Contamination.
This finding of C14 in essentially all fossils implies that these fossils are merely thousands of years old and not millions or hundreds of millions of years. In other words, C14 is now our friend.
That's significant because so oftentimes Christians will be told, well, carbon-14 proves that the Earth is millions of years old, when actually it's quite the opposite.
That's right. Now, in this program, I would like to deal with another big issue, and that is, why do other radioisotope methods give such vast ages in the range of millions to billions of years when applied to the Earth's rocks?
Okay, so carbon-14 we've taken care of, but there are other ways they measure.
That's right.
We've got to look at those too.
Yeah. So the rate approach, the approach that our team used on this topic, was to face up to the reality that most of the Earth's rocks do indeed actually contain millions to billions of years worth of nuclear decay products, not merely a few thousand years worth. So our task was to understand in an objective way why such high levels of nuclear decay products exist, given that, according to the Bible, the history of the world since creation spans only a few thousand years.
John, I think that's an important point, that your team took the data as it is there and didn't try to deny it, but said, well, wait a minute, let's really look at maybe why or what other factors could account for this.
That's right. Now, let's take a quick look at the assumptions that are made when these radioisotope methods are applied to a rock. The first assumption is that the rock sample has remained a closed system since the rock cooled from a molten state. In other words, neither parent isotope or daughter isotope has leached out or leached into the sample. That's been a closed system.
Okay.
That's the first assumption. Second assumption is that the initial amounts of daughter products can be known accurately. That there's some way of estimating accurately what the original amount of daughter product was.
Okay, they assume this as well. Okay.
Okay. The third assumption is that the nuclear decay rates have remained unchanged throughout Earth history. Now, the validity of the first two of these assumptions for a given rock body can be checked or tested by applying what is called the isochron method. I'm not going to go into that, but there is a way to determine whether or not those first two assumptions are true or not.
And what does it turn out?
If it fails to pass that test, generally that rock is not used for dating.
So that's a corrupt rock or the system somehow. But this test then says, hey, these assumptions really are valid at this point.
Generally speaking.
Well, that
yes.
leaves the third then.
All right. So what about the third assumption, namely that the nuclear decay rates have remained unchanged throughout Earth history? Well, that brings me to a breakthrough rate finding. We found that nuclear decay rates have not been constant throughout Earth history. Instead, during brief episodes in the past, they have been drastically higher than they are measured to be today.
I assume you're going to show us how you found that.
Right. Just what sort of research led us to such an astonishing conclusion? Well, first of all, it involved tiny crystals known as zircons. Here's the chemical formula, ZrSiO4, zirconium silicate, which are commonly found in granite. This is a microscope photograph of some zircons that we actually isolated in our research. And as I said, these are common in granite. Just some facts about zircons. It turns out that uranium atoms substitute readily for zirconium atoms in the crystal. So zircons tend to incorporate up to about 1% uranium when they form. In other words, these zircons are radioactive. Zircons tend strongly to exclude lead, a uranium decay product, when they form. So we can, with confidence, assume that the lead concentration when these zircons formed was 0. So that helps us with that second assumption.
That's sort of a check on that assumption. That's very good.
And thirdly, zircons are very stable. They have a very high melting temperature, mechanically are extremely hard, and hence are extremely resistant to weathering and alteration.
So this would speak to the fact that this is probably, or more oftentimes than not, a very stable and incorruptible way of checking these things, correct?
So that it's reliable.
Reliable.
You can assume that they've, in most cases, have been a closed system. So these two things relate to those first two assumptions. The zircons we studied were from a drill core from a 2.5 mile deep hole in granite in northern New Mexico, in this area of New Mexico. And that's the drill rig that was used, and this represents some of the zircons that we extracted. Now, uranium decay in zircon yields 2 stable end products. Lead, if you start with uranium-238, decays to lead-206, and helium. In the process of decaying from U-238 to lead-206, there are 8 alpha particles emitted in that chain of decay steps. And these almost instantly turn into helium atoms as they capture 2 electrons from the environment. But just as helium leaks out of a party balloon, in a similar way, it also leaks out of a zircon crystal. So helium migrates or diffuses through the zircon into the surrounding environment. Most often zircons are embedded in another crystal of biotite, and so over time the helium tends to leak out of the zircon into the surrounding crystal.
So you can test that by measuring how much remains in the zircon.
Right. It was found that large amounts, tens of percents of the helium from all the uranium decay was still retained in the zircons in this drill core. A scientist by the name of Robert Gentry in the early 1980s did these experiments to measure the helium retention, and he found these black numbers are his measurements, up to 58% of all the helium in 1.5 billion years worth of uranium decay were still in the crystal. The uranium lead age for these crystals was 1.5 billion years, based on how much lead was present.
Okay.
And also based on the current rate of decay of uranium. Okay, and in our work we measured 2 other samples from the same drill core, and one case at a slightly shallower depth where the temperature was lower, we found 80% of the helium present, and the other, which was at 1.4 kilometers, measured 42% present. So these are astonishing levels of helium retention in these tiny zircon.
John, there seems to be a consistency as well, that the shallower you go, the higher the number, the deeper you go, the lower the number.
Yeah, there's a good reason for that. The rate that it leaks out of a crystal depends strongly on the temperature. So as you go, we went deeper in the hole, the temperature got higher, and at these high temperatures it leaks out faster, so there's less of it left in the crystal. We were aware how fast helium migrates through many other solids, and we, based on that, we were confident that the helium would have all leaked out of these zircons were they truly 1.5 billion years old. Yet without knowing the actual migration rate of helium in zircon, we could not make a strong case that they were dramatically younger than that 1.5 billion years. We therefore launched a major initiative to measure the helium diffusion rate in zircon in an accurate way. So we obtained samples from the same core that Dr. Gentry had studied, and extracted 1,200 zircons in the same size range. I, working at Los Alamos, was able to get access to the cores that were still stored there, got samples from 750 meters deep and 1,500 meters deep in the core. We took these samples to the Institute for Creation Research, crushed them, separated the minerals, and then the final step, we had the zircons in a certain size range, very narrow size range, extracted at a lab called Activation Laboratories in Canada. Okay, and here's some of the zircons that we got from those cores. This is an electron microscope image, an optical microscope image. These were all within a narrow size range of 50 to 75 microns. That's approximately the diameter of a human hair. Okay, and then we contracted with the world's leading expert in measuring helium diffusion for us. And this was just a sketch of the apparatus he used. The researcher did not know who the sponsor was. Our goals are the site from which the samples were obtained.
And why is that important, John?
Well, the reason is that the measurements were unbiased by any of these issues.
So what you got then was someone just taking the rocks that you sent them, running them through the apparatus, and then telling you what the results were.
That's right.
There was no objective, there was no bias, or he just said, hey, these are the results.
Yeah.
That's what you want.
But prior to sending them for analysis, we did some predictions, which we published three years before the measurements were made. We predicted what the diffusivity would be if the samples were only 6,000 years old.
Okay.
And also what the diffusivity ought to be if they were 1.5 billion years old.
Which is what the other method said that they were,
right.
The other radioisotope
right.
method.
And so there was a difference of about 100,000 between these two predictions. And we felt that the measurements would easily distinguish which one of these was closer to the truth.
Because that factor of 100,000 is a very large figure we're talking about.
That's right. So we just could hardly believe it when we got the results back. The results fit this 6,000-year curve within the 95% confidence limits of the measurements.
And these are the results given to you by the world's leading expert.
That's right.
In measuring this.
That's right. Astonishing finding. The measured diffusion rates fit the 6,000-year prediction within the 95% confidence limits.
Now this is what good science is. You make a theory, you do an experiment, the experiment backs up the theory overwhelmingly. You've got pretty solid ground now in saying, hey, this theory shows itself to be true.
Yeah.
John, we left off by showing your team's, the rate team's estimate of a 6,000-year dating for these rocks, the diffusion rate of helium from zircon being confirmed 95%.
Right.
What are the significance?
Well, the issue here is how could most of 1.5 billion years worth of the helium still be inside these zircons when the direct laboratory measurements of the helium migration rate show that most of that helium ought to have escaped in just a few thousand years. So that's the issue.
That's the question.
That's the question. To express it in a slightly different way, we have two clocks, as it were, in zircon, each based on a distinctly separate physical process, which these two clocks disagree by a factor of 250,000 in their age. What's the conflict? So with the helium diffusion, we get an age of 6,000 plus or minus 2,000 years. With the uranium nuclear decay clock, based on the rate of uranium decay we measure today in the laboratory, we get an age of 1.5 billion years. So which clock if either is correct? What's responsible for this discrepancy? Well, our answer, based on some of the other rate projects we undertook, is that it's the helium clock that is the correct one, and that the reason for the large age of the uranium decay clock is that nuclear decay rates were much higher in the past, during brief intervals in the past, compared with today. Our study of helium retention in zircon showed 1.5 billion years worth of nuclear decay had occurred within the last 4,000 to 8,000 years. And we concluded that this means that nuclear decay rates have not been constant and the same as measured today, but instead have been dramatically higher during brief episodes in the past. We believe these episodes were during creation week, early in creation week, before there was any life on Earth, and then also during the flood.
And this would refute that third assumption that the rate has always been constant,
right.
Which would assume the conditions were always the same, and the uniformitarianism that we hear sometimes.
That's right. So where the error was that we were looking for, it's the error in that third assumption that nuclear decay rates have always been what we measure them to be today.
And your clock, the rate of that helium coming out of the zircon, as it were, that is showing that this is actually correct.
Yes, and this, of course, is a profoundly significant result. Two other rate projects pointed strongly to this same conclusion. So an immediate implication is that radioisotope dates based on the assumption of constant nuclear decay rates are in error by large factors, in some cases by factors exceeding 500,000. So it means the standard radioisotope methods for dating rocks are have huge errors associated with them.
And you have the tests of the helium, the carbon-14 in diamonds. I mean, some significant experiments showing that these dates are in fact in error.
Yes. A key consequence is that the concept of deep time, grounded upon the assumption of invariant nuclear decay rates, is simply invalid. Those who hold the Bible to be God's Word, hence, no longer need to be intimidated by the deep deception of deep time.
And I like the way you used science to show this is the case. This isn't, as so often people do, divorcing faith from reason or fact from the Bible, but we're saying, hey, let's look at these things. Let's really examine them. Let's take into account other ways of measuring them, and let's try to go where the evidence leads.
Right.
So, John, when the rate project ended, what was the response of the secular community to your findings?
Well, there were a handful of people that wanted to challenge us. So they challenged some details of our methods, and we answered those critiques very quickly, very solidly. And so once that happened, there was essentially just silence. They tried to ignore us. They've tried to ignore it, tried not to draw attention to it.
So they tried at least an initial effort to try to maybe poke holes in it. You guys showed that that wasn't the case, and now
silence.
Maybe it didn't happen. We'll pretend like rate never happened.
Well, I want to just give one other indicator that the radioisotope timescale is in serious error, and that is the finding of soft tissue in so many fossils from deep within the fossil record. For example, flexible blood vessels containing red blood cells preserved in a T-Rex femur that was reported in Science in 2005 by Mary Schweitzer. Photograph of the flexible blood vessels and the red blood cells.
Well, thanks a lot for being with us, John. This truly has been a wonderful program and some fascinating information that I hope our audience will follow up on.
Thank you. Thank you.
I want to thank you for joining us on this program. We looked at how, using radioisotope methods, secular scientists have concluded that the rocks in the Earth are over 1 billion years old. And yet the rate team using some other methods, carbon-14 and the diffusion rate of helium from zircon, have shown that actually the rocks, those same rocks, are only a few thousand years old. Well, it just goes to show you once again that we know what the Bible says is true, and the proof is all around you.